She's also a member of the National Academy that just came out with a report on pathways to space. She's a member of NIAC, and she's also recently won an award as a champion of change from the White House. I was very impressed with that. So, and she's a graduate of the Art Institute in Pittsburgh. Next door is Deepak Atyam, who is also somebody who I've followed quite extensively. Deepak is a co-founder of the SEEDS program down at UC San Diego, and is also known for heading up one of the first university groups to build, fly, and test a 3D printed rocket engine. For that, he won the Darlene Dom's DIY rocket competition last summer. So, and we're very happy to participate in that. Next is Jason Dunn, who, if you haven't filled out, there's a Made in Space raffle ticket to complete. And Jason is a co-founder of Made in Space, and also was a co-founder of Omega Envoy, which again was one of the lead student team, one of the only student team, led student team for the GLXP, and is a graduate of SU and from University of Central Florida. And then, of course, Manu Sharma from Infinity Aerospace. He's a co-founder. The great thing about Manu is while working on Infinity Aerospace, I know he was also working on graduating from Stanford, so I congratulate him on finishing the program. And with that, I'd like to get started on our panel. And what I would ask is if we could just go down the row and say, how did you guys end up here? I mean, why now? Why DIY? What's been happening? So maybe we can just go down and get, brief couple of sentences here.
Yeah, I feel like this is like a superhero's like origin story or something. I got here because in 2008 I was watching a documentary about NASA, and I thought it would be really cool to work at NASA. Essentially, it was a documentary that was showing all of the rocket explosions and things that were happening in the early days when NASA was trying to figure out how to send people into space, and they were talking about how they didn't know anything about orbital mechanics or rockets or anything, and they were figuring it out. And I was like, well, I don't know anything about space exploration. My background's in graphic design, and I just decided to write someone at NASA an email that someone I had never met, saying that I was a huge fan. And serendipitously, I got a job at NASA from that email, and it completely changed my life. So quite literally, my entire career in space exploration has started from 2008. So that's pretty much how I got here. And after I left NASA, I was really inspired by the concept that I could actively contribute to space exploration, and that there's a lot that I could do. And so I sort of made it my mission to tell other people that you don't need to have a formal science background in order to actively contribute to space exploration and scientific discovery around it.
So I got into this DIY movement altogether mainly because starting off with the projects that we had, we didn't really have much money and we didn't have much support. So we basically had to do it ourselves. And that's, I'm assuming, why most of everyone else is here too. I was fortunate to have worked with NASA for the past couple of years over my summers while I was in school. And during my time over there, I was able to meet a couple of engineers that were able to help me and assist me to move forward to some of the research that we're interested in. And that's some of the things that we're all going to be talking about soon. I'm absolutely sure about that. But basically, I got into the DIY movement because we wanted to do something. We didn't want to wait for other people to help us or for other people to say, okay, you can do it now. We wanted to do it because we had the ability to do so.
All right, I guess I got here, long series of events. It started with SEDS coming to NewSpace. But really, I mean, the reason I'm here is the same reason everybody in this room is here. We're all pioneers on the frontier of space. And, that's what drives all of us. it's neat to be on a panel about DIY, because when you think about the frontier, what you really realize is that, it's on the frontier that we invent new technologies, that we solve new problems and ask new questions. And it's the frontier where the hacker exists. Everywhere that there is a frontier, that's where hackers are, that's where the DIYers are. So with space, it's interesting because that frontier's never had the true DIY movement, and that's about to change. What's changing is we have disruptive tools that are allowing it to happen. We never had, we really haven't had the ability for the hackers to disrupt the space industry, and disruption's important. Columbus was a pioneer on the frontier. He found spices in the New World. That was for the food industry, for food preservation. What disrupted that was a guy named Frederick Tudor who invented ice harvesting. Completely different. It completely removed the need for the spice trade. So what we need today is the people who can disrupt industries in space and completely change the way space is done. That's why we created Made in Space, is to create a tool for anybody really to disrupt aspects of the space industry. That's, Sean pointed out that we're raffling off a free print. The printer will be on the space station in a couple months. It goes up on the next SpaceX launch, with the idea that any of you can come up with ways to be a DIYer in space and disrupt a really big industry in space, purely by removing the need to launch. It's finding a cheaper way to get to space by building your hardware there. I think ArduLab had a great example that they showed on the screen, that growth experiment for plants. It looked like that was 3D printed parts inside, am I right?
Yes.
Yeah, so imagine that these 8th graders could have an ArduLab in space and not just send it up with one plant growth experiment, but then use this printer to build several more iterations of that experiment in space. And then all of a sudden, launch cost goes away, launch requirements go away, and they can iterate on their experiment many times over. So that's what's happening with Made in Space. That's why I'm here. I guess I think it's why everybody's here, actually.
Cool. So how did I got here? I was, let's say this, Brian and I were classmates in a university in Embry-Riddle in Florida. And I think we've always been, so we have never came in DIY. We've always been in DIY. We've always been tinkerers. Everything we see around that has been built or has been created by someone, we kind of always think, how is this thing designed and what can we improve upon? And it's kind of like a very designer sort of fundamental ideology that we have. And I think everyone in DIY has it, that yes, we can make it ourselves, or we can design it. We can be the creators. I got in space because, my whole degrees, everything, it was in aerospace, and one of the key moments where I realized that I wanted to contribute something in space was, I believe in a junior year, where Brian and I walked in a room in a university, and they were working on a CubeSat, and we were thrilled to see that actually this screws and all this aluminum and all of these things will actually go to space. So we were kind of like feeling and touching it and say like, wow, this is going to space. It's pretty cool. But at the same time, we realized that we could not contribute directly to the project because there was so much of hierarchy, so much of bureaucracy. And at the same time, it took almost 2 and 3 years projects. It was absolutely nuts. Like if I would be graduated and I would have no idea what was happening with the project. And I think over the time, we started a different company. We went totally different direction. But I think it stuck back to us, said like, can we contribute now? Are the tools in the market that we can use and create a product that actually could solve that issue? And it's a very small issue. There aren't a whole lot of people doing experiments on board International Space Station. And for us, it was more of a practice in our normal day thinking that we want to create tools that enable people to do really cool things. And I think why now? I think the time was, so there's an exponential decrease, obviously, in silicon and faster computers. And we saw Arduino that came out, I believe, 6 or 7 years ago. And more than 1 million Arduinos, there are more than 1 million Arduino users around the world. including, I believe, 7 and 8-year-old making really cool robots and things like that. I think there was a threshold after certain users of Arduino and Raspberry Pi and sort of like open source platforms that it was easy to create more tools based on those ones because they were much more stable. They were widely available in the market. People had created ecosystem. There were sensors available. So because of all this confluence of all these technologies came in, we thought that it would make sense to actually build satellites or RDLab, for instance. And that's how we got in this arena.
Great, thank you, Manu. I have a question, which is, in the space industry, I'm always concerned about, reaching out to customers, reaching out to this community, and this is actually a question for Ariel. I want to hear something about your Space Hack Day, Science Hack Day. You almost have like an international footprint on that, so maybe you can tell me a little bit about that.
Yeah, actually, I just got back from Shanghai last week. So Science Hack Day is a 48-hour event in which scientists, designers, developers, and all different types of people get together in the same physical space to see what they can rapidly prototype with science in 24 consecutive hours. So the mission is really just about getting excited and making things with science. And it's just an amazing, chaotic, delightful, weird event. So Science Hack Day happens here in San Francisco, but it's also open for anyone to create in any city around the world. So now I think we've been in 35 cities, 15 countries. So I was in Colombia last month. Shanghai was last week. And then I'm going to Madagascar next month for different Science Hack Days that people are organizing. And I think the thing that's really great about it is the fact that it's super open-ended. So it's not about necessarily like, we've got these challenges and, can you figure them out in 24 hours? That's not what it's about. It's really about, just sort of seeing where your inspiration takes you and creating weird ideas that you're not necessarily sure about where they're going, and sort of seeing the serendipity that happens when you collide all these different people from different backgrounds, and actually see amazing, clever solutions come out of it, sort of just out of people's imaginations almost.
So how is it that, for some of the other things that we're doing, for like what's going on in the International Space Station, we have ArduLab, the Maiden Space, even for technologies like the 3D printed rocket engine, how do we engage this community? I mean, your effort is one way of engaging that, and I'd actually throw that out to the panel here. I'd like to hear something about reaching out to this community which wants to do DIY, which wants to get engaged in space. So.
It's been interesting for Made in Space to figure this out, and I think the reason why is what we offer is something entirely different than anybody's ever understood before. No one's ever manufactured their hardware in space. So, in the beginning, when we were just going out and saying, hey, we'll have a 3D printer in space, what do you want to use it for? It's hard for people to actually conceptualize that, and it's hard to really reach the audience. But what we've been doing is really like working with these people. So when people are interested, and we've got several dozen people like basically in queue ready to use our printer, we're working with all of those groups and those people to help them understand how to use it. And looking at an experiment and rethinking how it could be built if it were 3D printed, how to get in early in the design stage so that the entire thing is either 3D printed or designed to be replaced with 3D printed parts. But a lot of it is helping like show people the way. So maybe that's different for us because what we're doing is fairly different. You have anything?
So my thoughts are, like, how do we gauge the DIY movement, let's say, in space? I don't know how we would gauge it, but I do know that For instance, PhoneSat is a great example of a project that turned into a company, but it was started with that notion that people were making systems from content that was available readily in the market. And there's two things that you require in order to have that DIY space work really nicely, which is content availability as well as content reusability. So you can buy a phone or you can buy a processor, and then you can reuse other people's work and customize it to make it yours. And that's how kind of open source works. And I think we are doing really good actually, because DIY people are the explorers. They find these new markets, they find these new arenas that actually they can make something in that niche and do something about it. Perhaps it's for their personal curiosity or whatever it is, but DIY kind of enables people to explore different directions, different unique designs, and I think that we are seeing that a lot of that in space right now. Certainly with CubeSats, so as an example I mentioned PhoneSat, there's other projects that were funded on Kickstarter, as well as there are a lot of people trying to create ground station networks and things like that. So actually that's a great example. So when people started doing CubeSat missions, they found that it was kind of hard to get data back because there aren't really a network of ground stations that people can use easily. And there are big companies with the dish antennas, and they typically won't give you 5 minutes of time on your small satellites. So the people in the space community, they started like, well, why not we make a network of ground stations and give access to people who are in amateur ham radio frequencies, and they can essentially track their satellites for a couple of hours, and you can track or get your data from a satellite. It's over Australia, for instance, while sitting in US. So that enabled people to create new technologies and sort of new solutions and I think DIY kind of enabled all of that in a whole lot, in a great way. And I think gauging, I'm not sure, I think we can, I certainly know that it is a big movement. It is becoming big every day.
I think it's an interesting question because what we've seen at the university level is that one real easy way to get people into the movement is visibility. That's one thing that sometimes is lacked in areas, but for us at, like I said, the university level, when we got the press release for our rocket engine and we've successfully tested it, we actually had people from all over the world contact us, and we didn't expect that whatsoever. And it was amazing because it was sort of like we inspired people to do exactly what we did. A lot of people love space, and a lot of people love engineering. To put them together and how they can do it themselves is something that we sort of enable them to do in their own fashion, in their own way. We gave them an opportunity, and we showed them, hey, well, look what SpaceX, look what NASA, look what Aerojet Rocketdyne's doing, and we're students, and we did exactly what they did. And it was amazing to see the responses of the people all around the world that wanted to share their expressions and say congratulations, but also ask us how they can get into the movement, ask us how they can do their own things too. We have a lot of other people, a lot of universities and students that ask us, hey, you guys are doing really awesome work. How can we do some work too? And the best thing that we saw is visibility to get other people into the movement altogether.
That's a good lead-in. Do you guys have the video in the back for Deepak's rocket engine? And maybe we can cue that up and take a look at it, because I thought it was a great video. What I want to ask, or set up the stage for asking, how is it that our community, this NewSpace community, can do what it can to promote DIY? And in particular, I'm kind of thinking of the open source effort, and I believe your engine is open source as part of the requirement.
So what you're watching right here is the first 3D printed rocket engine from a university in the world. And we're really, really proud that the first time we created everything, it worked, and our first design was successful. We had no idea what to expect when it went off, but we were really excited when it did. But like Sean said, our source or our designs right now are open source. We shared it online with a community of engineers and inventors that want to do exactly what we're doing. We want to promote space. We want to see the innovations that everyone can do. We want to see the opportunities that are available by sharing our information, like the other members of this panel over here too.
So I would ask, what are the things that our community can do? And maybe I'll start with Ariel. You know, you've been really working on a global scale. What is it that we need to do on our end to help promote that, whether it's open source, or what would you like to see?
Yeah, I mean, there's definitely a lot of work that still needs to be done, but one of the most important things, I think, is or one of the mistakes that I see in both government and non-government space industries is that people make the assumption that there's all these people who already know that they're interested in space and they're just dying to get involved. And that's true for some people, but there's this entire community of people who would think that it would be amazing to do something in space, but they don't identify as space geeks. They don't identify as people who regularly follow NASA news or anything. You know, there's a lot of people out there that if you approach them and you said, you know, would you want to work at NASA or would you want to send something into space, they'd be like, of course, that sounds amazing. But they don't necessarily follow this community at all, and they're not like craving, you know, the latest open source space stuff. So I think one of the things that's really important when talking about engaging a wider community in space is to not assume that it's just the people who have already raised their hands and said, I'm a space geek. It's actually much wider than that. It's reaching out to people from all different backgrounds, all different areas, people with and without capital. You know, I think there's been a good job of, you know, making stuff open right now, which helps serve people who are already in part of this industry, but I think there needs to be a lot more work done in terms of actually getting people to realize that they can contribute to space, but it doesn't mean that they need to drop everything, become a space geek, or get a PhD, or start a startup in the space exploration industry at all. The level of accessibility is much wider than that, and so I think it would be great to see people who are more able to pop in and out of, you know, doing things in space, and that it doesn't need to be something where they become the next Elon Musk or work at NASA even to do it.
So I think I probably can think of one step that everyone can take, perhaps in immediate future, is that a lot of us have kind of worked on great projects or something related to space. And if those projects can be shared with people, let's just put them online and write a nice story about it, kind of like a whole brief summary of what you have done and what could be the prospects of it. And just put it online and share it with people, because it's much easier for someone in India to find out your work over internet than finding you and then asking you the solution for it. And these are the precursors we saw with, let's say, RDU Pilot when it got, when Chris Anderson had released that. There was a whole blogs about it, and they would find questions and they would find answers, and there was some person doing certain things, and he found, I mean, this was an ever-evolving process, and the only way was it was enabled was because people were online, as well as they were sharing their experiences online very freely. And if they created an autopilot, and at that time it was very questionable, because can you make an autopilot from scratch things?
I think you're referring to what eventually ended up being 3D robotics.
Right.
Right. Exactly.
Yes, that's totally right. And I think it's one of the biggest open source projects that we've ever seen in drones, for example. So I think that is the first thing that everyone can do, is let's put things online and share it with people, and have the conversations going about creating cool things.
Deepak, I mean, tell me what you think about all this.
So altogether, the ideas that we have, so for keeping our community open, I think it's essential that everyone that is an everyday average person has an opportunity to be a part of our maker community. To have some type of makerspace is a great place to share ideas, to actually create things. And I know we're more on the space side and we're focused on that, but that doesn't mean that everything we do is fundamentally just gonna be simulations or gonna be on the computer, just CAD models. I mean, what's the point of doing all that if we can't actually create anything? If we have a makerspace, things or opportunities like that and communities around us will open up avenues of interest and will generate a lot more interest from students, from older members of the audience, or people that are like working that have interest but might not be able to pursue it because of their own careers at their point in time. But maker communities, I feel, are really essential to be able to show that there's an open opportunity for a lot of other members of the community to work with each other and to do what they want and to explore everything that's out there too.
Yeah, and Jason, maybe you can talk a little bit about how you as Made in Space have been trying to reach this much broader community, which I find, as an educational community, Peter Platzer commented that it's highly fragmented. From the business standpoint, you're thinking of customer acquisition, and how do you, how is it you guys have been reaching out as a company?
Yeah, it's an interesting question. We're makers, we're DIYers at heart. That's kind of why we created the company, but we created it for the DIYers to use, right? It's a tool for the DIY community to use in space. Obviously, NASA wants it for utilization, build tools and parts for the crew, but at the end of the day, it's for this community to really use and do something that's never been done before, and I guess it had, like I said earlier, it's been tricky to find those people. We finally figured out a good process to really connect with those groups. And then I think I would just agree with what Ariel was saying, that it's about just telling people how important space can be, and that at the end of the day, it's about doing something worthwhile, doing not just important work but worthwhile work. And a lot of people say, why space? Why do we need to spend money in space when we have problems here on Earth? My answer has always been that we're going to solve all the biggest problems on Earth by going to space. And once people realize that actually is really true, that if we have to live in space, we have to become 100% self-sufficient, and we have to recycle all of our own water and grow the food and process the waste and collect all of our own energy. Every single one of the biggest challenges on Earth is a challenge in space. And to go to space, we have to solve those challenges. That means that life on Earth will become a lot better by going. So that's always been my message, and that's what gets people excited, is that by going to space, we make life better on Earth. And that's the end of the story.
Yeah, okay. And then, Ariel, on your Science Hack Day, what kind of, for the events that you do, how many people actually show up for that, and how many, if you could put a number on the number of people that you've connected with for this?
Yeah, I mean, I would say it's probably modest, because I really focus on having quality.
Well, you're only one person.
Yeah,
right?
well,
So
I'm one person, but also, they're not as large as they could be. So the one in San Francisco is the largest. We have about 200 people at each event. This year would be the 5th year of it in San Francisco. Events around the world are more around 100 per event. So, they're modestly sized, but it's, really about making sure that they don't grow so large that you don't feel that you could actually get to know the majority of the people over the course of the weekend. So it's really focused on sort of the quality aspect of it. And it's just great to see the sorts of things that come out that are really unexpected. My favorite hack that I tell everyone about is a hack that came out, I think, a couple of years, where we had some guy who wanted to create a device that would detect when he needed to shave, like a beard detector of sorts. Like a really silly.
He's really focused on a bunch of other things.
Yeah, it was really silly, and it was this device. It was like a USB microscope, and he held it up to his face, and it got an image of all the stubble on his face, and he wrote some basic code and used an open computer vision library, and it drew the lines around the stubble on his face, and I thought this was silly, and I wasn't quite sure what it had to do with science, but we leave it completely open-ended, so the things people create are ridiculous. and fun.
Well, I could see
but-
that software being used on the ISS at some point.
Yeah, well, so a particle physicist was watching this hack demoed and said to himself, wow, that's actually a genius way for how to detect cosmic rays in a cloud chamber. And following Science Hack Day, like, wrote an entire proposal for how to detect cosmic rays in a cloud chamber using the original code and open computer vision library someone had used to detect if he needed to shave or not. And so that's what I love so much about these events, and I think that's really what's great about it. It's the impact is really not that it's this huge scale, but it's in all these different cities around the world, and you get these delightful little clever solutions that, is the science industry okay without these solutions? Sure, they'll be fine, but it's kind of reckless not to allow this sort of serendipity and clever ideas to really emerge and sort of grow. And so you get these clever solutions, but more importantly, you get all these different people who now feel that they can actually contribute to science and do fun things with it, but it's not necessarily going to be life-changing. They don't have to drop everything and say, oh, I want to pursue a career in physics now. It's really more about the idea that science is just another material that you can manipulate or a fabric that you can work with. And equally for scientists, learning that you can work with a variety of different tools and people from completely different backgrounds is also pretty important.
Yeah, as we look at the new space industry, there's a lot of analogies to the computer, the age, computer internet boom, and all that kind of stuff. And part of that relates to the number of people that are involved. That on the internet you had kind of open standards, everyone could develop to them. That's why some things failed and some things succeeded. Those things that were open actually succeeded. Having worked on a bunch of DIY space stuff, everyone says, what are you going to do about the dreaded ITAR issue on this? And I know people are, that's kind of come up on the 3D rocket engine issue. For a lot of the companies that are out there, they're like, oh no, I can't release that information because of restrictions. And so I'd like to, get some comments about the ITAR, how you guys have been dealing with that. Is that an issue? Can we carve out a part of the space where it's not a problem? Because I see with Ariel's workshops, they're global in nature. Space is a global issue, global problem, global participation, huge untapped markets, brick, so forth. So tell me about what you think with ITAR, and maybe I'll start with Deepak here, because the engine. I know that came up with the whole 3D printed engine stuff.
Yeah, it definitely came up a couple of times, especially with the university. The biggest thing that came up with the university, first of all, was safety, because they thought students were going to be handling dangerous substances. Then the next thing that came up was ITAR, regulations altogether. And it's interesting because most of the things we're doing were based off of patents that are definitely all online for everyone to see. And it's not like we were absolutely recreating everything of a rocket engine. We're using past designs that are in books all around the world. We were using work that physicists and engineers have done that is published around the world. And we told our university that the work we're doing is based on, obviously, the past, and it's great. We are innovating new designs and new features. The thing is that for us as students, being at a UC, everything that we do, we cannot restrict ourselves to foreign students altogether, so we have to be open to everyone, and that's great, because we are a group of students that wants to innovate. We don't want to restrict ourselves to opportunities that are out there. In terms of regulations, luckily with the work we were doing, and because we're at UC San Diego, a UC altogether, it was okay for us to be doing our design work as long as we publish it with the right people and we do the correct work in terms of our designs altogether. But the thing was, like with the university, it seems like it would have been a much bigger problem. Fortunately, it wasn't as large as we expected. It was a problem with DIY rockets, and I know it was with Darlene, who started the group to do the competition of designing your own rocket engine and having it judged by a group of engineers. And I can see how that was a problem with the open community, because we don't, obviously you don't want this type of technology to fall in the hands of wrong people. It's rocket engines, and they can be dangerous if it could be fall in the hands of wrong people. But this technology is also a little bit expensive right now, which is unfortunate. But our rocket engine costs about $5,000. And the printer to use those rocket engines are anywhere in the scope of $500,000 to over $1 million. And those types of technologies aren't necessarily open to a community of people, readily accessible to someone that could damage us and our society as we know it right now. In the university sense, they themselves haven't seen it to be too much of a problem. We are innovating. Luckily, they haven't seen it to be a huge issue in terms of international regulations for specifically what we're doing right now.
Yeah, and I think, Manu, you mentioned the 3D robotics. The exercise in 3D robotics was that you could build out of essentially Lego Mindstorms hardware an inertial navigation system, which thus put Lego on under ITAR, and I believe the Lego Mars rover was also being debated as being under ITAR. But maybe you guys can talk about your own ITAR experience.
Sure. So one of the reasons I believe 3D robotics is based, their factory is based in Tijuana, is because of ITAR. So you can actually create autopilots and sell them across the world. So yes, ITAR is an issue, and I think one of the ways we addressed is, so when we started making RD-Lab, there was people coming to us like, this is going to be ITAR compliant or not, and things like that. Well, I was far away from being a US citizen, and I'm still not a US citizen, and then I could not work on a lot of things that we've developed if we were, let's say, not open source. But because we were open source, our designs were based on Arduino, and there were people involved across the world to contribute in designing certain aspects of our product. So for us, we felt it's fine because who will be liable to these designs? They're available already online. So anyone actually can create RD-Lab if someone was so persistent. It would just take a long time. And if that thing is just a matter of time, yeah, essentially, that's how we kind of address the ITAR. And the other thing is, we talk a lot about hardware. ITAR comes in, obviously, if you're trying to create some hardware and launch it in space. I really personally think that there's a vast field in data. So we have, I think, enormous terabytes of planetary data from many missions, and we continue to get a lot of data. And if you will find people creating programs and codes and services based on those data, and it's part of this big open source culture and DIY culture. And I think that arena is even more interesting because you don't have these restrictions, and everything is kind of is on computers, and you can program them really fast. You can get that fast feedback loop happening. So people tend to create really cool things out of the data that we have from space. And I think that is an arena where a lot of people can contribute very fastly on DIY stuff.
Okay, and maybe I'll ask Jason to comment. And then also, I'd like to open it up to the audience here, and we have 2 microphones on either aisle. And if anyone has any questions for the panel, please just line up, and we'll be able to address those questions. But Jason?
I don't really have much of a comment, but there is, I think ISS is a good case study on how ITAR, how we can work around ITAR, because I forget the exact regulation that allows it, but NanoRacks is able to take hardware from the U.S. and send it to Russia and launch it, or launch it on a Japanese launch vehicle, and there's and then it goes and operates in by foreign individuals on the station, and there definitely is regulations put in place to allow that to happen, and my suspicion is that exact system will be leveraged in other aspects of the space industry, and that will kind of help us get around ITAR. Great.
Okay. So questions, if you can state who you are and question.
Yeah. That's Al Globus, San Jose State. It's going to be really cool to have a 3D printer on the ISS, and we think about all these things you might do. But I would like you to maybe address there are limitations. I mean, there's very limited in terms of materials, bead size. Puts a bottom end on your smallest feature. Has to be operated in the glove box. I was wondering if you could just sort of go through what are the other limitations so people have an idea of what you really can do and what you really can't do.
Yeah, thanks for bringing that up. That's a good question. So that, By no means are we trying to say that 3D printing is the end-all be-all, especially where it's at today. It's a relatively early technology. The technology itself has existed for over 2 decades, so it's not like it just came out last night. But it's increasing very quickly in capability. So the first printer, the one that will be up in a couple months, does thermopolymers. So if you check our booth, you'll get to hold and feel what we're talking about. ABS plastics, polymer composites, things like that. There's resolution and tolerancing that constraints, just like any other machining process has. But even that technology right there is capable of doing a lot. So once we started this project, NASA did a study, and they looked at all the things that have broken on the space station to date, and they found that 30% of everything that is broken could have been replaced with a polymer-based 3D printer, such as what we're setting up. So that was actually a surprising statistic even for us, that actually 30% of NASA's broken parts could have been printed. But we're working on the next step. So, bringing out new materials, higher capability manufacturing process to kind of cover the rest of the gap. But this is the beginning of a whole new field. So I talked about disruption earlier, how we're enabling everybody here to disrupt the space industry, but 3D printing itself is disruptive. And if you look at curves of disruption, it's a long trend of not doing very much, and then it spikes and it takes over an industry. So today it might not be exactly where it needs to be for every single thing that we need to put in space, but we're going to slowly get there, piece by piece.
Great. Your name and a question, please.
Good morning, guys. My name is Austin Kreitz with Rockzip High Balloons. And we're a bunch of DIYers at heart, and we're trying to get people to have access to high-altitude balloons to do their own experiments in space. Do you guys have any ideas of what we could focus on in order to best help out the movement to get people, enabled to do their own experiments in space? On balloons in particular.
I'll open that up to anybody on that.
So I think my suggestion, I don't personally know, but I have launched a balloon to near space long back. I think people are fascinated about potentials of what you can do with, let's say, 100,000 feet. What kind of images can you get? A lot of people actually are doing imagery, sending iPhones and cameras and things like that with a balloon and taking some photos. But what can you do beyond balloons? Can you actually launch an airplane, a small RC aircraft from 100,000 feet and try to stay afloat for a couple of hours and see, can you get data? Can you launch a rocket from a balloon? Interesting things like that. And I think those will be interesting ideas that I would kind of like to pursue, or I would like suggest you to pursue, and give people examples on. People like end-to-end solutions, so you give them examples of this is how you can do project A, project B, and you need to show them until project Z. And then I think once you have so many options, people think that they can do a lot more, and then the ideas start meeting and new ideas start coming.
If you can, get on blogs and different opportunities like that online for other people to see. Tell them how you guys started. That's the best way, and if they know that you guys started from an idea, and you guys came to a company fundamentally. And if they know that, it's you guys as people, normal people, you guys aren't eccentric or really. You guys are very smart people, of course, very smart individuals. But I'm not saying you guys have to show them that the average person can do exactly what you guys are doing. But you guys are obviously where you are because you guys started it first, and you guys are moving forward. But get on blogs and show them that you guys did what you did. And everyone else has the same opportunity to do similar ideas such as that.
Yeah, and also I would mention the Stanford Space Initiative. I think these guys did a balloon program, like a global balloon program, earlier during the summer. I can connect you up with that. And expanding on what Manu said, I would look at the Google Loon program, which it's a great opportunity to work on communications. Yeah, you send your payload up, but tell me about real-time communications, amateur radio license, everything they have to do with sensors, processors, and transmission technology, transmit and receive. But anyway, that's just my comment.
Thanks, guys.
Yes, sir.
Hey, Sean. Charles Miller. I'm a co-founder of NanoRacks and with NextGen Space. I just wanted to have a word of caution on using the NanoRacks exception to ITAR. This is a really important issue. It could be a major risk for anybody taking this approach. The exception NanoRacks uses the ISS exception, which was developed under international agreements. It's a unique exception. It's not probably a good model for expanding mini do-it-yourself unless you're working on the space station. And basically, NanoRacks is not exempt from ITAR. It just does, instead of going and getting a license from State Department, it does it through NASA. And NASA, as a US government agency, has their own processes and is actually liable for protecting export, sensitive information. But that's what NanoRacks does. So be careful of that. It's not like it's a void of export license. It's just under the NASA banner instead of a license with the State Department. So for everybody.
Yeah, great. Thank you for that clarification. Yes, sir. Your name and your question, please.
Hi, my name's James Parr. We're actually building a Maker DIY telescope for hunting asteroids. So I love this panel. It's sort of very close to my heart. But my question is, do you think there's a grand challenge or a moonshot that the DIY movement can go after? What could we do if we collectively put our heads together and went for something?
Sure, I think I would love to see in the next decade or so, when people start settling, people start having hotels in space. I would love to have a DIY hotel up in there, or a complete spacecraft made by people. I think the big goal for, I think, what I can say is just to have inherent capability of doing pretty much 95% of things that people do in space. I think that's kind of a big, hefty goal by itself. Can you make Star Tracker, for example, open source? If you make Star Tracker is one of the very expensive parts of satellite. Can you make that open source? And once you make it open source, can people start using it for making cheap satellites that can track things like that? So I think, yeah, like bits and pieces, and then collectively, a lot of things, when it's available to people, then they can actually make really big things. Yeah. You have
No, that's perfect.
I was going to say, I mean, there's great thing. I still think, Google Lunar X Prize is it's amazing to see what different teams do, and some of them are more DIY scrappy than others. But one of the, if we're going off of wish list items that are that should be accessible to more people, I think orbital debris is definitely an area where I've been a bit disappointed in that there is obviously growing concern about it. There are more and more groups assembling to tackle it, but I haven't seen something that's really opened it up to a wide variety of people to put ideas around and solutions to. And I think it's an area where there can actually be quite a bit of innovation and creative ideas into how to solve it. So that's certainly an area I think that's on my wish list that I don't know, I hope something will emerge over the next couple of years around that, that really opens it up to a wide group of people to iterate on.
Yeah, and I think you can look at Deepak's success in having a competition, and then over here we have Adrian, who just recently won the lightning pitch for his cube cab. So Adrian, maybe introduce.
And I wanted to follow up on the ETAR comment. Wanted to get the panel's comments on how we're thinking of dealing with the ETAR issue, which is relying on the CubeSat standard. It's an open source standard, public domain, so it's specifically exempted from ETAR regulations. It also puts very strict limits on how the satellite interacts with the rocket and with any other satellites, specifically pretty much doesn't. So under that model, it would seem the launcher worries about the launcher, the satellite maker worries about the satellite, and other than through this public domain standard, the two don't need to interact, and that would seem to exempt all the ETAR worries. The rocket maker doesn't need to worry about giving any technical information to the satellite maker because they aren't. The satellite makers just worry about the experiment. In your opinion, would it be a workable model?
I don't know if anybody wants to comment on the compartmentalization of that. Or it seems like a good idea. It's working. Press on. I mean, I think the whole ITAR reform is just an ongoing discussion, and stuff that's developed here in the United States, it's like any trade barrier. They never really work. Maybe you can Yes, sir, please.
Doug Beeson, USRA. Just have a comment and then a question. The comment is that I recently retired as chief scientist from Air Force Space Command. And what we had tried to do before I left, one of the reasons I left were because we didn't have a culture like y'all have in DIY. But one of the things we tried to do was to actually convince the government to do 3D printing in space. But the answers that we got back from the generals and the politicians were, why do we want to print toys in space? And so part of the problem is one of communication. How can you communicate to let people know really the power of what you want to do? So the question that I have is that if you want to do something like 3D printing in space, what can you do that just can't do it better? That is, it's great to do things a little bit better in space with a 3D printer, but what you want to do is do something that nobody can actually do and they haven't even thought of. And an example of that might be, how can you design a satellite with a 3D printer where you don't have to build a bus, you don't have to do anything at all because you're building it in space, and therefore, 90% of the weight is with strusses, the bus itself. So the question for DIYers is, what can you do that nobody has really thought of before, and just not to do something better?
Well, you just took the number one response I was about to give you was building satellites in space. Honestly, that's a lot sooner than most people think. We'll be demonstrating how that's possible even on the first printer once it gets operating in a couple months. With that exact idea that today's satellites are designed to survive launch, just like everything else that we put into space, but that, a huge amount of our mass is structural mass to survive launch. We have fasteners to hold things down and harnesses. All of these things can go away if you can manufacture there, if you can design things not to need to survive launch, or even to survive any type of gravity field whatsoever. So, and that's the kind of the bigger point is, if you start rethinking your space systems to be something that is only needed to survive in the space environment and not in the launch environment or any other, the Earth environment, the clean room environment, just space environment, then you have, you kind of have a new playing field to work with. And the thing that I'm most excited about is how that changes the structures that we build. So we call them zero gravity structures that would never have to survive their own weight. They could be very, very sparse, very thin, but perfectly designed for their application in the space environment. And when you couple that with 3D printing and the software and the simulation tools that we have available, now we can design structures that not only are zero gravity structures that can't survive their own weight, but they're also structures that we could have never manufactured before with any other means aside from 3D printing. So I'm talking about, evolving structures, building, starting with just like a blivet of a block and having a computer algorithm evolve the most perfect structure for your need, and then 3D printing it. So when you combine the software and the simulation and then the manufacturing technology and do it all in space, it really just opens a playing field. So satellites might be one example, but you could probably just go down the list, anybody working on any space project, and start to think about how to do it differently.
Yeah, a very, very important point for engineering design. Yes, one last question, sir.
Hi, Sean, panelists. I'm Amir Blackman from Space Angels Network. So first of all, you guys are talking about things that you're doing in a very mortal and mundane way, and I think it shouldn't kind of go over all our heads that what you're doing really is world-changing and amazing and unique, and so I applaud you on that. And my question is, you're opening the floodgates now, right? You just made RGLab easy to access, so much easier to access, and 3D printing on the space station has now opened up so many fields, and what you've done is triggered a whole world of a new importance in thermal materials, because now maybe not only are you going to print on the space station, but just outside the space station, right? And a million other topics that open up because of what you're doing. So I have a capacity question for you, and that is, the space station is limited in size, so how many RGLabs can go up, and what's going to be the process for who gets selected to go up once the pipeline is full? And from the 3D printer, how are you going to manage that same process, and how long do you think it's going to be before your 3D printer starts printing more 3D printers?
So I think I can answer the Audilab question. There is enough room in International Space Station for, let's say, tens of CubeSats that you can be deployed inside, and you can connect to computers and run your experiments. The nice thing about it is because it's commercial, and you can buy a time slot for 30 days, for instance, and after 30 days, your payload is ejected out and perhaps stored somewhere or incinerated at some point or brought back. So there is a cycle always happening every 30 days. So you can ship your payloads there and get them installed and then get the old batch out. So I think, I'm not sure what the number is on the capacity side. What I do know is that there will be a lot of, I think NanoRacks currently has they're using full of their capacity, I believe, with their CubeSats, and they're doing great with their payloads. And I think so far they have launched about over 100 payloads, and it's certainly going to increase, and I know that it can be magnitude higher than that, capacity architecture-wise in International Space Station.
I think my answer, it actually ties into it quite well. You know, one part of the answer is that, you know, when we have experiments being manufactured on the space station, you know, perhaps it's integrating with an RGU lab. The idea is that now we don't have to launch the entire experiment. So what may have used to taken up a 3U volume, 3 U's of CubeSat, maybe we can just launch the 1U and manufacture the rest out of material that we have on station. So we can actually minimize stowage volume this way. And actually working on ISS, sending its payload, we understand how big of a problem stowage actually is. Not just in the fact that there's a limited amount of space, but it's also hard to find things. So sometimes a crew member, we found that it may take less time to print a tool that a crew member needs than for them to go hunt it down and figure out where it's at. The bigger part, though, is really about how to use what you've got there. So we're developing right now a recycling technology that will recycle not just the parts that we build and make them into feedstock again, but also to turn plastic waste on the space station into feedstock. So now we're repurposing what's already on the space station. So it's not, we're actually reducing the problem with stowage. So today you can, I forget the exact number, but there's a lot of plastic waste where almost all the food packaging is plastic waste. The foam that is packaging around all the experiments and payloads is a polymer-based foam. And it's all stored in a very non-dense format. The foam takes up a lot of space and the packaging takes a lot of space, and then we incinerate it and throw it back into Earth's atmosphere when we get, you know, it fills up too much room. We can package that down into the really dense form of feedstock, takes up less volume, and then build with that. And then we can build with that over and over again. And now we don't have to launch feedstock anymore. So we can get to the point where it's very self-sustaining. And it really is also the first instance of real ISRU, in situ resource utilization. So I think that will be part of the key to making this all, you know, completely sustainable.
Amazing, thank you.
Good, thank you. And yeah, I really like your comment. This is really very exciting. We've got some great entrepreneurs, and I'd like to give Ariel the last word on the panel, or next to last word, but go ahead.
About anything specific, or?
No, just, you know, here you are, you're up here, you see what's happening. Tell me, you know, how this is gonna play out. I mean,
Yeah, I mean, I think right now, you're seeing a lot of stuff about making everything really open, which is great, but I think really the next step is in truly making all these things accessible to people from different backgrounds and different countries, and people without, you know, a lot of capital to go off of. So I think I'm excited about everything being opened up, but I think it's even more exciting to watch, I think, over the next decade, things becoming really disruptively accessible to people from all different walks of life about this. And I think it's also going to be really exciting to just see the sort of unexpected, delightful things that emerge from this, because I think a lot of people view or pigeonhole the DIY community as just a group of really excited geeks who will make anything you want them to, and that's just not it. It's really about the serendipity and unexpected solutions that come out of really making this accessible to people who have completely different mindsets and focus on completely different things day to day.
Yeah, and I would expand upon that. In my mind, the DIY community includes people like Elon Musk and Richard Branson, and all the way down to the school kids that are working in Manu's workshops. So with that, I'd like to have everyone thank our panel, and I assume everyone will be around for later on. Thank you very much.